Okay, we're going to talk about factoring quadratic expressions, and we're primarily going to focus on when the lead coefficient is not 1. But in order to get to that point, I want to go through a couple problems where it is 1 and give it an opportunity to find what we're going to refer to as magic numbers. You may have seen this process before. I need two numbers that multiply to be, in this case, positive 6 and add up to be positive 5. And I do like including positives even when the positive sign doesn't have to be there. It just helps kind of reinforce. When I see six factors of 6 and I see a 5, I'm thinking 2 and 3, or I might be thinking 1 and 6, depending on signs. But if I need two numbers that multiply to be a positive and add up to be a positive, I need positive, and 1 and 6 aren't going to get the job. They won't add up to be 5, but 2 and 3 will. And if we can find those magic numbers that take care of, in this case, the positive 6 and the positive 5, we know that we can factor this. I know my first terms have to be b's, and my last terms can just be placed from my magic numbers. So a plus 2 and a plus 3. So there's a case with a lead coefficient of 1. Okay, we're going to take a look at another one with lead coefficient of 1, and then we're going to move on to some more challenging lead coefficients. So in this case, I need two numbers that multiply to be negative 14. I kind of like having a negative there because I know the signs have to be opposing. I need one positive and one negative, and they have to add up to be positive 5. So if the signs of my magic numbers are opposing, I really need two factors of 14 who subtract to be 5. My only options, 1 and 14, 7 and 2. In this case, 7 has to be positive because it outweighs the 2 to give us a positive result. So just like the last slide, we can now place those. We know this guy factors. We know my first two factors have to multiply to be m squared, and my last two factors, or my last two terms, excuse me, are 7 and negative 2, our magic numbers. Okay, but as you may well already know by now, this does start to get quite a bit more difficult, particularly if we're guessing checking when we get lead coefficients other than 1. This would be a pretty easy guess and check because we've got nice prime number 5 at the beginning and negative 1 at the end. It wouldn't be too bad, but I'm going to go through our process that we're going to use for more challenging problems. Same deal as far as coming up with our magic numbers, but now I take my first times my last, I get negative 5. I need magic numbers that multiply to be negative 5 and add up to be negative 4. Because they multiply to be a negative, I need a positive and I need a negative. In this case, I need the big to be negative, and my only options are to have a negative 5 and a plus 1. And here is where you better be careful because it's really tempting. We've been trained on lead coefficients of 1. It's really tempting to do something like this. If you were just kind of half paying attention on this, you may treat this like the previous slides. But if we take a quick look, you're going to hear me say this repeatedly. First times first has to equal first, and a times a does not equal 5a squared. And you're going to hear me say last times last has to equal last. And of course, 1 times negative 5 does not equal negative 1. So that isn't what we're doing with our magic numbers. What we're going to do, and I generally out of my magic numbers will pick the smaller number or the more prime of the numbers. In this case, I'm going to choose 1, positive 1, and I'm going to set my outside product. What do I mean by that? Here's a phrase I think we all should be pretty familiar with, FOIL. That just describes the process of how we multiply our first times our first, our outside products, our inside products, and our last times our last. I'm going to set the outside product to be, in this case, and you can choose either one, positive 1, and our variable is a. So I need to get just a 1a there. And my only option to do that is to put an a here and a plus 1 here. We know we have to have an a term here. And at that point, we're really done with the thinking. The rest is just automatic because I'm going to go back to the product of my firsts. First term times first term has to equal first term. So I need a times 5a to give me my 5a squared first term. And likewise, last term times last term has to equal my last term. So I need positive 1 times negative 1 to give me my negative 1. And that all seems kind of fishy until you learn what the checking step. The checking step is the inside product. Take a look at our inside product. I'm going to put it up here. I get negative 1 times negative 5a. I get negative 5a. There is my other magic number. And that's a great way to check this process. So I made quite a mess there. I'm going to clean that up because you should need a little bit less illustration as we move on. So we're going to go through a number of these. At any point, feel free to pause and give a problem a try. Okay, so here's our process. Positive 3 times negative 8, negative 24. I need magic numbers that multiply to be a negative. 1 plus, 1 minus. And add up to be what? Not 2k, but negative 2k, or negative 2. So if my signs are opposing, positive and negative, I need two numbers that multiply to 24 and subtract to be 2. 1 and 24, no. 2 and 12, no. 3 and 8, no. But 4 and 6, yes, provided the 6 is the stronger term. I make the stronger term negative. Okay, so I have magic numbers. What does that tell me? It just tells me it factors. I've still got some work to do. But remember the next step. I'm going to set the outside product to be either positive 4 or negative 6. I'm going to go with negative 6. No real reason. I think a lot of times I'd choose positive 4, but negative 6 is going to help me illustrate the next step. So where am I going to get that negative 6? I have to get the negative 6 with factors of 3, which are 1 and 3, and factors of negative 8, or 8, which are 1, 2, 4, and 8. I have to get a product of 6 out of those. Well, there should only be one way to do it, unless we could have prior factored out a monomial, but the only way I can do that is a 3 from here with a 2 from there. A 3 from the k squareds and a 2 from the last term, but the product needs to be negative, so there's my negative. And I really want to emphasize that at this point you have it made, because first times first equals first. So 3k just needs to be multiplied by another k to give me k squared. And last times last equals last. Minus 2 times plus 4 gives me minus 8. So I've used this magic number, and now I'm checking for my other magic number with my inside product, and there's the 4k's that I needed. There's my plus 4. Pretty slick, but we're dealing with pretty easy numbers right now. 3, negative 8. Going to be a little different story when we have numbers like 24 and 18. But we're going to get to some where the numbers get bigger and talk about that as well. Okay, 5 and negative 8. I really like the 5 out front. At least it's prime. I'd rather it be 1. But we're going to go for factors of negative 40. That requires me to have one positive and one negative that add up to be positive 6. Since they're one positive, one negative, another way of saying that is I just need factors of 40 that subtract to be 6. And I could go through the list, 1 and 40, 2 and 20, 4 and 10. Oh, 4 and 10. There it is. 10 and 4. So at that point, I've got my magic numbers. I know this thing factors. I, of course, cannot just place those numbers. I have to set my outside product to be either one of those. I'm going to choose -4. So my outside product should be -4 times b. I'm hoping later on that my inside product is +10b. That's going to be my check step, but it just kind of falls in your lap. Okay, I need a factor of 5 and a factor of 8, and my guess is you probably don't have to draw all those out like this, but for illustration purposes, I need a factor of 5 and a factor of 8 that's going to give me 4. So 1 from the b's, 1b, and 4 is my last term, but there's a negative, -4. And then again, I mentioned earlier, you're gonna hear me repeatedly say first times first equals first. B times what equals 5b squared, 5b. Last times last equals last. -4 times what equals -8 plus 2. And here's that nice check step. There's my +10b. Again, reminder, at any time, feel free to pause this recording, try a problem ahead of time, and see if we work it out in similar fashions. Okay, now here's something that I could take 6 times 14 and get 84, and maybe I should, but I want to start illustrating how we're going to search for bigger numbers. So I'm just going to list this as, well, what is +6 times +14? It's +6 times 14. I need two numbers that multiply to be 6 times 14 that add up to be -25. And you'll see why I'm going to leave that as just 6 times 14. Okay, if they multiply to be a positive, add up to be a negative, they are both negative, which means these guys are in agreement. I do truly need two numbers that add up to be 25, multiply to be 6 times 14. So I'm going to start a search over here. 6 and 14 are two numbers that multiply to be 6 times 14, of course. But those guys, if I make them negative, give me -20. And so at this time, I might just start stealing factors from one or the other. In other words, I could take this 14 and I could just turn it into a 7 because that's a factor. Provided I take the 2 remaining from the 14 and combine it with the 6. So -12 times -7 should be equal to 6 times 14 because it has the same factors. And that gives me -19. Well, I'm looking for -25. And what I learned is if I go from -6 and increase my negative to -7, I'm really going in the wrong direction. So I'm going to look for a number smaller than 6 that I can get. I could get 3, for instance. Let's see how that happens. I can get a 3 by stealing from the 6. If I take a 6 from the 3, or a 3 from the 6, I'm left with a 2 times the 14, 28. If those are both negative, -31. And I'm not doing a very good job of guessing, but I did learn this. I need a number between -6 and -3 because I need to be between -31 and -20. Well, I look at 6 and 14, there's no way I'm going to get a 5. But I could get a 2 from the 6, I could get a 2 from the 7, and I can get a 4. I could have a -4 and a -21. And there's my -25. Now, might I have been able to be more efficient at that? Absolutely, but I just wanted to show process we can go through to eliminate. So I'm going to set my outside product. I'm going to choose -4, in this case, -4x. How am I going to get that? I don't have a factor of 4 here. I don't have a factor of 4, but I do have a factor of 2, and I have a factor of 2. So I'm going to use a 2x and a plain old 2, but it better be -2. And now we can just pass it on to just a beginning algebra student, because first times first equals first. 2x times 3x gives me my 6x squared. And last times last equals last. Negative 2 times negative 7 gives me my positive 14. And let's not forget to check my inside negative 21. My magic numbers were negative 4 and negative 21 that we found, and that's our check. Again, if you just want to work with factors of 84 instead of this, that's fine. Okay, little tamer numbers, and I'm pretty good with factors of 40, so I'm going to go ahead and find factors of negative 40 that add up to be positive 3. Two numbers multiply to be a negative. I need a positive, which is my strong term, and I need a negative. So I really need factors of 40 that subtract to be 3. Well, 4 and 10 get me to 6. I need to be closer together than that. 5 and 8 get the job done. If 8 is positive, 5 is negative. In this case, I would choose negative 5 and set my outside product to it. Negative 5b. Why? Because at negative 5, I know I'm just looking for a 1 and a 5. If it's 8, I'm looking for a 1 and an 8 or a 2 and a 4. So I like prime numbers there. How am I going to get a 1 and a 5? Well, it's got to be a 1 from here. 4 doesn't have a factor of 5. And a 5 from there. 1b and a 5, but negative 5. First times first, 4b, equals 4b squared. Last times last equals negative 10. Negative 5 times positive 2. What's the check step? Plus 8. If you want to give that one a try, pause. Okay. I'm going to just write 4 times negative 30. That would be negative 4 times 30. Again, you want to write 120 there? Great. It may be helpful to do that for you. I need two numbers that multiply to be this negative. One positive, one negative, and add up to be positive 19. Since the signs differ, I need two numbers that subtract to be 19, multiply to be 4 times 30. So I could just start with these. 30 and 4, those subtract to be, I wish they subtracted to be 19. Those subtract to be 26. And if I think about this for a second, if I need them to subtract to be smaller than 26, I need them to be closer together. So I'm going to look for numbers between 4 and 30. For instance, I could steal a 5 from the 30, which would leave me with a 6 to go to the 4. 6 times 4, 24. I said, if I was to subtract those guys in the correct order, I could get a 19. So I got lucky there. Not too bad. So my magic numbers, negative 5, positive 24. Hopefully by now you know which one of those I'm going to choose. If I chose 24 as my outside product, I'd be looking for 1s and 24s, 2s and 12s, 3s and 8s, 4s and 6s. But if I choose negative 5, I'm just looking for a 1 and a 5. 1 from here. 30 has a factor of 5 for me. So 1m and a 5, and once again, should be minus. Home free. First times first equals 4m squared. I need a 4m. Last times last equals negative 30. I need a plus 6. And it's really tempting to move on, but I'm in the habit of checking. There is my plus 24, my other missing, or my other magic number. By now, you're probably certainly ready to try some of these on your own. here's one. If I multiply 3 times 49, I get 147. And I'm not so quick with my factors of 147. So I'm just going to leave this as positive 3 times 49. I need factors that add up to be negative 28. So if it multiplies to be positive, adds up to be negative, I need two negative factors, which means I just need two factors of 3 times 49 that add up to be 28. So in my search, I could say, well, what about 3 and 49? Those add up to be 52. So I'm just going to start stealing some factors here. How about I take the obvious 7 from 49, combine it with the 3, 7 times 3, 21. I'm adding those up. Wow, I got lucky there. And I got 28. So my magic numbers are negative 7 and negative 21. Okay. No doubt which I would select, not that you couldn't use 21 or negative 21, I would choose negative 7 because negative 7, the only way I'm going to get it is with a 1 and a 7. So negative 7m is going to be what I'm going to set my outside product to be. Well, I'm using a 1 from the 3 and a 7 from the 49. 1m, and I need a minus 7 to set my outside product. Done. First times first. M times what is 3m squared? 3m. Last times what is positive 49, negative 7 times negative 7. Let's check. Minus 21m. There's my minus 21. I already used my minus 7. Love the magic numbers. Okay, one more. If you have not tried to work ahead on one yet, really want to encourage you to try on this one. So pause, and then turn it back on when you think you have a conclusion. Okay, 3 and 30. I think I'll go ahead and multiply these out. I'm not too intimidated by 90. I need factors of 90, positive 90, that add up to be negative 19. And boy, these ones are pretty obvious, I think. But I definitely need two negatives to multiply to be a positive and add up to be a negative. But if they weren't obvious to you at this point, you could certainly go through the 3 and 30, realize two negatives, we're adding those together, we're at 33. I need smaller numbers. I'm going to try to increase from 3. So I'm going to go up from 3 by maybe stealing a 5 from the 30, and that leaves me with a 6 from the 30 times the 3, 18, and that gets me to 23, which gets me in the right direction, but I need to go further. I went from 33 to 23 by increasing from 3 to 5. I need to continue up. So I could say, well, maybe I'm close. Maybe I should have stole a 6 from the 30, leaving me with a 5 times 3, 15. I'm closer yet. I'm at 21, but I need 19. So I look for a 7. Can't find a 7. Look for an 8. Don't have an 8. Look for a 9. Well, I can get a 9 if I steal a 3 from the 30. Combine it with this 3, I get a 9. If I stole a 3 from the 30, I'm left with a 10. And my guess is most of you probably already saw that that's what we're looking for. Negative 9 and negative 10. I have no real preference between those two. I'm going to go for my outside product to set to be negative 9n. I'm probably a 3 and 3, but I could be a 1 and 9. 1 from the 3, 9, nope, can't get a 9 from over here. So yep, I'm a 3 and a 3. So I need 3 n's, and I need my last term to be a 3, but it better be a minus 3 in this case. And we got it made. First times first equals 3n squared. I need another n. Last times last equals positive 30. I need a negative 10. My inside product confirms what I already knew about my magic numbers. They're an awesome approach to this, and certainly, like in this case, seems like a lot of writing over here. My guess is most people, upon seeing the 90 and the 19, could come up with 9 and 10 very quickly. I hope this was helpful for you, and feel free to visit this again to kind of reinforce. But this is really a great process for finding for factoring quadratic expressions where the lead coefficient is not 1.